We're taking a look at some of the architectural changes between version 1 and version 2 of my raycasting engine. More specifically, we're taking a look at the changes to the pipeline. First of all, what is pipelining? If someone were to make a machine that did three things, A, B and C, to some input data, it would do A, then B, then C on the first set of data, then the next set of data goes through A, B and C as well. This isn't efficient though, as parts A and B do nothing while the data is being processed in part C. It would be more efficient to split up the machine in parts and send in the next data as soon as A is done processing the first data. It processes data much faster. This is called pipelining. Each part is called a pipeline stage. The speed of the pipeline is determined by the slowest stage. If you have a slow stage, it's like having a traffic jam. It doesn't matter if your car can go fast, if there are other cars in the way. Version 1 already had pipelining. Each column of pixels was produced by a different pipeline, but one part was particularly slow and slowed down the whole pipeline with it. This part does the bisection algorithm, and it is slow because it loops back. The same data goes through it multiple times, and while that data is looping, the next part has to wait. In version 2, I solved this by duplicating the component multiple times. Instead of sending the data back around, it gets sent to the next copy of the component. This way, the different copies can be in different pipeline stages. In fact, with this change, I split up the pipeline in so many stages, each stage only takes one tick to complete. This creates another problem though, latency. Although a new frame would be shown each tick, each of those frames still took a lot of time to be processed. This means when you start rotating in-game, that would only become apparent if all the frames that are already in the pipeline get shown first. This is probably more than 40 frames. Another issue is the new screen. After I replaced the screen, that became the new bottleneck. The belt-based display can't display a new frame every tick, and the new texture scaler also can't handle that speed. So this additional speed isn't helping much. However, we can use this additional speed for something else. Instead of sending a new frame through the pipeline each tick, we send the next column of pixels of the same frame, and those columns of pixels get reassembled at the end back into a full frame before being textured. This way we need only one copy of the pipeline instead of 256 copies. This saves a lot of combinators. I hope my explanation was clear. Thanks for watching.